It's working now?
Yes, now it's working. Super. So let me just paraphrase quickly. So you were working in AI strategy for Audi and Volkswagen. Now you're a professor for machine learning. Interesting move. So you moved from industry to science. Why?
Yes, so there is no single reason actually for this move. So it's a combination of multiple reasons. And maybe the most important one, or the one that drove me most to do this step, is that I wanted to do research. Yeah, obviously. So this professorship is not a common professorship as it's used usually in technical universities, where you have 18 hours of lecture per week, which reduces half of it, so it's only 9, and the remaining time is actually reserved for doing research, and it's also well funded. So I'm getting, or I got one ground funded scientific employee, and I have a lot of space to build up a research group. And this is also what drove me through my whole career. I was always interested in generating new things, creating new stuff. I also had the possibility to do this at Audi, and I enjoyed my time at Audi very, very much. We had developed a lot of cool, innovative, new stuff and new product ideas, and I was creating a lot of ideas. And I also was creating a lot of research ideas, but at some point you always have to bring these ideas into productivity or into a product and make money out of it. And this is where actually my interest stops a bit. Yeah, I want to create the idea and want to show that it works, and I want to answer the scientific questions, but I'm not that motivated then to do like the hard work of bringing this stuff into production. So that's not where I'm good at. Yeah, I'm good at creating ideas and showing that stuff works and applying technologies to new areas. So I'm more a creative, scientific guy. So that's my nature. So this was one thing. And the other thing is, the other big reason is that I enjoy having the freedom to decide on my own what I want to research about and what projects I want to do. So I spend a lot of time actually convincing managers at Audi and the VW group that machine learning is important and we should do this and that. And then a lot of decisions have been made, which have been great, but there have also been decisions which were made due to some political reasons or some company internal reasons. And I actually prefer doing the stuff in a way I want them to be done. Yeah, and not being steered by somebody.
Okay, thank you. Interesting. So a move back to science to actually enjoy the freedoms that comes with it. You're researching computer vision for intelligent mobility system. What does that actually mean?
Yes, so basically it's, first of all, I need to say that this title is actually something that you cannot choose. Yeah, when you are called as a professor, this is already, when the university searches for a professor, the title is already done. You cannot change it. Yeah, so I would probably have preferred to call it computer vision, yeah, because it's more compact. But it's computer vision for intelligent mobility systems. So it's built of 2 parts. So let's first explain computer vision. I guess nearly all of us here in this call know what computer vision is. Let me illustrate on how I see computer vision. So if you imagine like any arbitrary scene, let's say a crossing in Berlin, and then you stop the scene, you stop the time at the scene at some specific point of time. You have this crossing, which is packed of information. And there's actually a lot of information there. Some of this information can be perceived by us humans. So we have kind of a sensor set, like our ears, our eyes, smell. You can feel some touching on the skin, but there's plenty or even very, very, very much information that we cannot sense, like radio waves or like all the little particles which are in the air. So there's a lot of information. This whole scene is packed of information. And then we use some kind of sensor. In most cases, we use some kind of a camera or imaging sensor where we persist a little portion of this information into some digital format. Okay, so you have this whole information, and then for the camera system, you somehow collect a few light beams or light rays which reach the camera sensor, and then this camera sensor is packing this stuff in somehow encrypted format, yeah, which we usually have in 3 layers, which is taking the intensity of this light in red, green, and blue colors. And then I see computer vision is actually the goal of computer vision is to get as much information back from this whole scene of information out of this little piece of encrypted data that we have. So this is my abstract general interpretation of computer vision. And the sensors that we use to collect these little pieces of information can be a camera sensor, it can be a LiDAR sensor, it can be a camera imaging sensor. For computer vision, it's mostly imaging sensors, or the data we get is somehow in an imaging format. And then we use computer vision to get information. And I also always like to divide the information that we can get back from this encrypted data in different categories. So there is the obvious information that has been collected by the sensor intrinsically or by the sensor set itself. So we measure, for example, the intensity of light. So it's very easy for a specific point in this image to tell the color that was collected. It's on a bit more abstract level. We can get models back, like there is a car, and we can get the color of the car. But there's also like information which is indirectly captured. For example, the temperature that has been there, yeah, the amount of degrees that has been there in the air. We didn't measure directly, but we can probably derive from some correlations that there are between the temperature and the clothing people were. So if they all wear hats and big jackets, then it's probably cold. Or if we see some snow, we can derive that it's probably cold. And then there's also information which is simply lost, like radio waves that haven't been detected in the image. And this is computer vision. That's the definition of computer vision. Yes. The other
well, actually, so thank you for the introduction. Actually, and then, by the way, if there's anybody in the audience today that is interested in this, and perhaps also is interested in working in an academic environment, I suppose they could contact you. I saw that you were recruiting, right?
Yes.
Exactly.
So, yes, for this specific position, we are currently filling it, so it's not open at the moment.
Okay.
But there will be, of course, open positions for getting a PhD in the future.
In computer vision in the future. Great. I want to go back to your previous position. So, I mean, you joined Audi as a data scientist in 2014. That's quite a long time ago by current standards in the field. What was it like back then? What was it like in the early days?
Okay, so 2014, this was like 1 year, or let's say a quarter of a year before the diesel crisis. So Audi was flourishing a lot. Everybody was in good mood. I remember some meetings that we had, some of the first meetings that were some top management presented numbers that we're reaching. So they always presented like the amount of cars sold and compared it to the main competitors like Daimler and BMW. And I remember some meetings where they said, yeah, we will have, like in 1 year or 2 years, we are at the top. If we continue with this growth, we will sell the most cars, more than Daimler in China or more than BMW in Europe. And the bonus will be high and so on. Yeah, so pretty good mood, at least in this first level. But then, yeah, somehow this diesel crisis, it had a lot of impact actually at the work in the 6 years where I spent there. So first was the diesel crisis, then was Corona, and the mood changed a bit. A lot of the top managers have been fired or have been replaced. And actually, I was working in the technical development, and in these 6 years, I had 7 different heads of technical development. And this was somehow a pretty dynamic area to work in. And it was pretty hard, actually, for somebody like me who wanted to convince this company to do more machine learning. Because every time I convinced somebody that machine learning is important and I had him or her on my side, they replaced it. So they replaced him, they replaced her. Okay. So I had to preach this again and again and again. And I didn't do this alone. So we had some group of machine learners which have been there and which said, okay, we cannot engineer everything on our own without using machine learning techniques for automated driving, but also for like making smart productions. So there are a lot of application areas, and we always try to convince our managers to do some more investment in this and drive this more further. And what I was really wondering when I came to Audi was they actually had two different departments which have been working separated from each other. One was within the chassis department, and the other one was within the electronics department. And actually the one sub-department of the chassis department was developing driver assistance systems, and the one in the electronics department was developing or was working on autonomous driving functions. Actually, it was the other way around. Sorry, it was the other way around. But the thing I want to say is there have been two departments individually, not connected to each other, which have been working on driver assistance systems and autonomous driving. And this was the first time I realized in such a big company, decisions are not purely made on the facts, but also politically driven.
I understand. Thank you for the story, rather interesting. So I know that you really care a lot about making the company more capable of utilizing machine learning. And then actually, if I look at the broader field, I noticed, or we all noticed last year, that Daimler stopped focusing on autonomous driving, while the Volkswagen Group, of which Audi is a part, actually seems to be doubling down on its effort. So how do you see developments? What potential do you see for the use of machine learning in automotive?
Okay, first of all, I don't think that Daimler really stopped working on autonomous driving.
Okay.
Probably they got some development of it, but I'm pretty sure that they didn't come to the conclusion that autonomous driving is not a future area for their business. I just don't believe that.
Okay.
The possibilities I see is, of course, if you think of automotive and actually machine learning or data-driven products, the one thing that everybody recognizes is autonomous driving. But there is actually a lot more potential. So if you know the processes which are present in such a big company all day, there's a lot of optimization. Then another big thing is production. So producing a car is pretty expensive, and if you can make it just a few cents or a few euros cheaper in producing a car, you can save a lot of money. And I think there's a really high potential in optimizing the internal processes and the production systems to be more effective, or even to support the decision makings in the company, to probably make more fact-funded decisions to go in some directions. And I think this is actually the biggest potential in automotive.
Okay, thank you for that. So, you know, companies are actually working to use more machine learning. They're trying to ramp up their data stuff. Are there any specific challenges that you think that need to be highlighted? What they need to do, particularly also if they're not startups, but if they're already established companies like Audi?
Yes. So actually, my experience is you either do it or you not do it. And what a lot of companies try is to do it a bit, and this is simply not working. So that's what this is what my experience, what I saw from a lot of companies in the past years. So if you want to do machine learning, you have to do it, and you need to know what this means to your company. You need to change processes in your company. You need to adapt decision processes. You need to lay down stuff like you have done it before, and accept that you have new things which come with some uncertainty. And this is like, I think the biggest recommendation I can give is, if you want to work with machine learning, it's not enough to just hire 1 or 2 machine learners and then put them in a room and let them do some stuff and give them probably some data. You need to integrate them in your all-day business and you need to have a data or a machine learning strategy where you know exactly how you integrate this machine learning team and the processes into your product development and in your production system.
So to some extent, if I got you correctly, you're saying, I mean, one part is the technology, but the other part is the whole organizational setup. And I think you were highlighting, you're highlighting kind of the organizational challenges. I want to actually take the opportunity, if I may. So I asked attendees if they have any questions to you, and I see some coming up from the attendees. So one of them is, I mean, you're now back in academia, so to speak. You also obviously were in academia and did a PhD. And there's this question of, you know, in the 7 years that you've been at Audi and Volkswagen, what was your relationship like with the academic community? So the industry, you know, the combination of industry and academia, how did that go for you?
So I was working in pre-development. So our task was actually to come up with new ideas and new technologies, which can be integrated into the cars like in 5 years from now. And there we did a lot of collaborations with industry. So of course we collaborated with the Technische Hochschule Ingolstadt because it's next to Audi from the location. But we also tried to contribute in the research community. We built up some partnerships with Professor Schmidhuber and Sepp Hochreiter, for example, where we had good collaborations, PhD programs. We had PhD students in our labs doing some research for us. So I was like always connected with the research community. The one thing which was, which we didn't do is we didn't publish any publications. We didn't publish papers.
Thank you. There's sort of a second question, second part of the questions that I'm going to try and summarize that I think go in the direction, you earlier mentioned the organizational challenges, and of course one wants to do more, possibly also deploy, kind of clear the way for these kinds of new technologies. Did Audi, or due to your experience, the larger companies kind of try and do it all on their own? I mean, you mentioned some academic collaborations. Also, do you actually then collaborate with companies offering support or freelancers, or is this very driven by internal kind of decision making?
I think this depends on the company. Audi was always like collaborating with a lot of companies, but now the last thing that I knew from VW, from the VW group, is that the goal is to integrate more and more of this development into their own subsidiaries. So they founded this car software organization, and the goal of this car software organization is to bundle software developers, and machine learning developers belong to software developers. So they bundle all the development for all cars in this one company with the goal to create an operating system which is then running on all cars of the group from Volkswagen, of the Volkswagen group. So the trend is actually going to more internal employees developing this stuff. And this is the reason, because the complexity is growing and growing. So the lines of code that are present in a modern car is a lot. It's more than you would expect. So it's more than in a rocket or whatever, or I think it's even more than Facebook has. And if you buy every piece of this code from different suppliers, you somehow lose the overview. And then you have a complex system which gets out of your hand at some point. And this is what happened. So the strategy is now to bring everything together in this one company and develop the thing, like from scratch in a good architecture, which is compatible to Tesla and all the other startups.
Thank you for that, Torsten. I've been told I have time for one last question. Actually, the last question I wanted to focus on data and machine learning. So there were some questions coming up from attendees, and I know we've also spoken, so to speak, how much you focus on data and how much you focus on machine learning. And I'm guessing some of the attendees are wondering, how clear is it to companies? How important are the data? How are they handling data from different sensors? And so how do you see that relationship of data to machine learning and autonomous driving?
It's actually a hard question because there's so much involved. So what I always try to establish is like having one department which has access to company data, and then can give this access to machine learning developers. What was the case in practice is that you had to collect your data on your own, make sure it gets annotated well. You have to make sure that the data quality is good, and then you used it for your machine learning. And this was like not very effective because you had to overcome the same problems. You have the privacy regulations. I was working, for example, with cars from the interior, with data from the car interior. You have a lot of privacy related data there, and you run into the same problems again and again. And my idea was always like to have a central data department, which is controlling all the data and which has a basic understanding of how important this data is for machine learning developers, and which can make this data accessible for the machine learning developers. Because in most huge companies, the data silos or the data storages, they grow historically in different departments. They are not connected to each other, and you have to do this once.
Thank you very much, Torsten. Thank you for the interview. Thank you for being here and sharing your insights with us. I hope towards the attendees, I hope I've done justice to the many. I saw very many questions coming in. I hope I've done them some justice.
Yes, thank you to Chris and thank you to Torsten for the great session. I also see that we have a lot of questions here. I will suggest that you connect to Torsten after the webinar today and ask him directly some questions.